Okay, let's jump right in. Just quickly checking. Priyank and Vishal. Priyank is here. Vishal is not dialed in yet.
Hi, Shankar. Hi, Jay.
Oh, you are.
Yeah.
Oh, okay. Your co-host. Can he also make Priyank a co-host if he wants to share something? PRI. Yeah, excellent. Thank you. So we're already 4 minutes over. Thank you everyone for staying. Um, this is it's a nice small modular update, and I think there are some larger principles I would like to highlight here. We have been talking about use cases and requirements and things like that. So my name is NK Shankar, um, and I'm currently not with any company. I do some individual work on the ONAP TSC, and also do consulting. But I have been a lead on with this use case for several releases, and I'm a use case lead. And this is actually a very good example of, I think we've always been working with the project PTLs, and there have been teams of people who are on the use case side. They work very closely with people who are on the project side. I think it actually works well, and some of the themes we sort of imbibe this discipline of putting down requirements only when we sort of think that they will we will have resources to meet those requirements, and we go through this there's a requirements process and an architecture process, and that all hangs together very well. So this particular presentation is all about configuration management, and it is about the radio access network, the WAN, and that's aligned with ORAN. So like I said, it's a small modular update, but the larger story is very interesting. It's a use case which works with the ONAP projects and the PTLs, and it seeks to make sure it is well aligned with ORAN because it's a 5G SON use case that's facing the radio access network and alignment with ORAN CUs and DUs and the ORAN interfaces. And we also wanted to make this work as modular as possible and as reusable as possible. So I'm co-presenting with Vishal and Priyank, and we listed a whole bunch of names of people who have contributed to this work over several releases and will be involved in implementation and testing. So the context here is in the ONAP 5G SON use case. So the picture on the left at a high level, the blue box is ONAP modules and components. So in DCAE, for example, there's a VES collector that gets data. It analyzes it. There's an optimization engine. There's a policy engine that coordinates decisions. And the orange box in the bottom is RANSIM. It's the simulated radio access network, which has network functions like CUs and DUs. And over the releases, we also now have an abstraction of the near real-time RIC, where we have an A1 termination and a RAN application. But this is not a full CU/DU or a near real-time RIC. It's the abstraction that is needed for the use case to be able to develop on this A1 and O1 interfaces. So all actions that go to the simulated RANSIM come from a controller, which is STNR. It's a variation or variant of STNC. The blue box, which is the ONAP part, that maps to the ORAN SMO. If you're familiar with ORAN architecture, the service management and orchestration. And the orange box is pretty much the radio access network. And we have this well-defined interfaces, O1 and A1 in ORAN, and we make it our business in this use case to be aligned with O1 and A1. Like I said, this is all about configuration. And in ORAN O1, you can directly configure the network functions, and then you can indirectly influence it using A1 policy messages. But one key thing to note is that the data that comes back from the RAN network functions back to the SMO or to ONAP is all over O1, the CM, FM, and PM, the configuration fault and performance. Okay, so same picture drawn a little differently. In our SON use case, the blue box on the right is the RANSIM. Here, the blue boxes are all use case specific. The orange boxes are ONAP platform components, and the yellow database. Oh, I don't know why it's yellow. So the RANSIM is a simulated RAN. And so those interfaces A1 and O1 are the one that are ORAN interfaces. On the top left is where data is analyzed. There's an algorithm that optimizes, keeps track of performance data and things like that. On the bottom is the RAN configuration data store, and it's embodied in the CPS project in ONAP configuration and persistency service. The network controller you know about, the SDNR, and so in the middle, this green control loop, it's a loop. Messages go to the simulator RAN and data comes back. And over the releases, for example, if you have fault messages and performance messages, they flow through the VES collector, go to the microservice, and it has its database. It has a data store for KPIs and alarms. But this talk is about configuration. Configuration is a non-trivial problem. And whenever you're managing anything, any network, you're managing network functions, and especially in the RAN, you're managing CUs and DUs. Any intelligent application needs a copy of the configuration to do the job effectively. You can't keep querying the network every time to check its configuration. You can get updates and you can do snapshots. So the theme here, the whole message here is when you make changes in the network, updates come as notification messages and they flow through the VES collector because it's aligned with ORAN. And you need an efficient mechanism to update the data store, and that's what this talk is about. Configuration messages, configuration updates come as notification messages. They are processed and the database is updated. And so now you understand the overall picture. Let me formulate the problem precisely, because this problem, when you dig into it, it's pretty substantial. And so these are our design approaches here, which is the first bullet. In this ONAP use case, we have a copy of the RAN NF configuration in the CPS database. And Priyank will talk about CPS. And any configuration change to the RAN network functions can be done over O1 by SDNR, but it could be done by some other internal mechanism. So we don't always know if the configuration changed unless we get the message. That's the third bullet. We assume, as per ORAN, that all configuration changes, you get a VES notification. Fourth bullet is, if you want to maintain this consistency, you need to process these messages and give a lot of thought to how you process notification messages, because the volume can be very high. And then the fifth bullet is you first do the update and then make it available to any application that needs it. The last two bullets are maybe specific to ORAN or any YANG device or a netconf device, which is in ORAN, the network function configuration is based on a YANG model. And so whatever is the YANG model of the device, we call that the primary YANG model. And it's significant that the CPS data store uses the same YANG model. So we have a model consistency, which is the primary YANG model. And the applications have information beyond that. We put that in supplementary models, which is outside the scope of this presentation, but it could be like plan changes, other things which are not in the network. So again, same picture again. So the next two talks presenters will basically talk about how do you generate the CMVES event message from the simulator RAN, and what are the issues there, and how we are aligned with ORAN O1. And Priyank will talk about exactly how you process this. So I'm going to hand over now to Vishal on the CMVES event generation. Please go ahead, Vishal.
Thank you, Shankar. Hi all. Good morning and good evening. So this diagram represents the CMVES event generation using the RAN simulator. And the left side, what we have is the ONAP components, the SDNR, DMAP, and VES connector. The first actor here represents the intended applications which wish to perform action on the RAN simulator or on the any G node B, whether it is a A1 based action or it is a direct own config action. So both actions are supported, and whenever any action happens, any A1 policy comes or own config request comes towards the RAN simulator. So the RAN simulator CUDU has the functionality. We have added the functionality which will generate CM VES formatted event, that and that event will give the exact payload what is being modified in the particular CAD node. So there are certain types of notifications which will be generated based on what kind of operation has performed on the nodes. And then yeah, can you go back to the same picture? Just I want to showcase the end of this flow. So when this event is generated, it will go to the VES collector. So run simulator pushes it to the VES collector, and then from the VES collector, it will map the domain, and it will push it to a particular DMAP topic. That is, here is a 3GPP provisioning output topic, and then this topic can be subscribed by the applications, interested applications. Yeah.
So
Thank you.
Vishal, quick question. Does that include day zero configuration?
Yes. So the day zero config also will create an event, but for the current release, we are adding not a day zero config, because it will create a MOI create notification. And what
Okay.
we are submitting currently, the MOI change notification.
Okay, so it's really the current is to do a proof of concept for day two configuration, and then sometime in the
Yes.
future include day zero.
Yeah.
Thank you.
Sure. So this we are following 3GPP 28532 specification to define the CMS event format, and where this specification has defined the notify MOI changes event structure. So as we see, these are the attributes will be reported in the notify MOI changes event. So what we have here is a object class attribute, which will give a particular parent object in the particular NRM on which the update has happened. So if I take an example, let's say there is a NR cell CU inside a CU, so then NR cell CU will be a object class here, and then the object instance, it will be the identifier of this particular object. In that case, it it could be the ID of this particular uh, parent object. Then we have the notification ID, which will give a unique ID for this particular event, generated event. And the notification types are the fixed ones, which will be like whether it is a MOI create, a delete, or MOI change operation. Then we have the event type. So event time is basically when this event has generated, when the action has performed on the a simulator or CU or DU node. And then we have the system domain. So this will be based on which domain this event has generated. And we have a MOI changes attribute. So this is again a array of objects, where each object is a single NRM update itself, and each object will have a certain set of attributes, and these attributes will treat as a single event itself. Likewise, if you see each object will have its own notification ID, then it will have correlation notifications which will define on which notification it has correlated, and then it will have the source indicator on which particular NRM data tree element it has done action has been performed. Then we have the path parameter, where it will give a particular X path location for the data tree element on which the action has been performed. And then the next attribute is operation, which will give what kind of operation has been performed. It could be a create operation, merge operation, or delete operation. Delete operation. Yeah. And yeah. Okay. So this is a sample of a CMS event, which is being generated using the RAN simulator. As you can see, it will have the VES event format, where it will have a common event header and the CM domain specific attributes. If you go to next screen, yeah, we have just zoomed it. Okay. So this event will have the common event header where we have the common event header attributes, same as the other domains, and the standard defined fields are the CM domain specific attributes. So where we have defined the href attribute, the href, the highlighted one, where it gives a particular host name or a particular IP address of the device on which this event has been generated. Then the notification ID is also given by this MNS producer or this gnode B. Then there is a notification type. Here we are giving this is a MOI change event type, and then system name. The MOI changes is the one where it will give a bulk of NRM updates. Likewise, we have a single NRM update here, single object, where it has given a notification ID. Then there is correlated notification. And since it is not related with any other notification, it's empty. We have additional text, and then source indicator, and then the path attribute, where it will give the path to the to this data tree element on which this action has been performed, and then the operation will come. So based on the operation, the value attribute will get varied. As we see, the operation is a replace operation has been performed. So the value will give only the value portion for this particular attribute. If it is a multi attribute change has happened, then the value section will contain all the attributes on which the replace operation has been performed. Or if the operation is a create operation, then the value section will contain the entire newly created object structure. And in case of a delete operation, the value section will be empty. So in this way, this event is getting produced from by the RAN simulator. Yeah, thank you. Thanks all. I will hand it over to the Priya.
Yep. Yeah. Thanks, Vishal. Hi all. Greetings for the day. So like before I start talking about like how CPS is placed in the 5G SON use case, I'll first briefly start with an overview of our CPS components. So basically we started our journey with with the CPS core and the CPS data store. So basically the heart of the system is CPS core. So which is like for CPS, basically CPS stands for configuration and persistency service. It's a cloud native, Yang native persistent service. We can handle any Yang model data using this component. We can add in various Yang modules and data at runtime. Basically, we don't have to change any schema and it can accept data at runtime. So since this component is based on Yang, we have support for validation. Of course, we have CRUD operations, and whatever is being persisted in the data store, we can query it back. So we have query support as well. And there are like two important concepts in CPS core, which we call data spaces and anchors. So basically data spaces creates a separation, a user application separation. Let's say some client wants to have their data being separated from other applications, so we have feature for that. And there's a concept called anchors which supports instance model separation. So this was about CPS core. Now we have NCMP, which is like our network configuration model proxy. Basically, we introduced this proxy to simplify access, simplification of the access of the network CM data. Basically, it hides the complexity of addressing using a concept called CM handle, which we introduced. So CM handle is one point where it is able to address the network functions. And basically NCMP leverages a CPS core for storing its own data and the configuration management data itself. Then the other component is DMI plugin. So basically this acts as a reference implementation for us. In ONAP we have ONAP DMI plugin, but there can be other third-party DMI plugins as well, which we will be talking about later. So the main responsibility of DMI plugin is it's a data model inventory plugin. It provides an abstract view of data, which is like the CM data as published by the network function, and it has to be strictly Yang. And we have model, basically it is modeled as Yang, which we can use to describe the network functions. Then we have inventory, where like the network functions that will be exposed by NCMP. So this because of this DMI plugin, we basically it enables integration with other multi-vendor EMS systems, and also it allows integration with other network functions, just for an example, like ORAN O1 functions. So this was an overview of the CPS components we have. So next next we have like how CPS fits in the 5G SON use case, since like this SON use case actually requires an up-to-date data view of the network, which is actually persisted in CPS. So CPS is able to provide the up-to-date information for this use case. So the flow starts from an ORAN device, basically this ORAN in the left hand side. So this basically ORAN device is capable of emitting a VES standardized event. Here we are calling it as VES event, which is being consumed by our ONAP DMI plugin. So here the main responsibility of our ONAP DMI plugin is translation. Basically we map the identity required by CPS and translate it to a DMI data ABC event. So we'll be talking about this DMI data ABC event in the next slide, but this basically this format of event is understood by our other CPS components. So NCMP actually consumes that DMI data ABC events and uses CPS code to persist any change or creation or deletion in our data store. So once the change is being persisted in our data store, and we have an actual view what the data is, so we actually raise a ABC and LCM events for our client applications. So all the interested applications can actually leverage those events in order to update themselves. So
Quick
as I was
question.
Yep.
Your DMI plugin, is it able to differentiate between manage elements and manage entities as described by O1 interface?
I think it would depend on the message. I think we are capable of reading the messages, so I think it would be able to make an intelligent decision based on that.
Okay.
I would say this, Mudassar, this work, the details of the implementation is ongoing, but anything that can be sent over the VES message can be mapped into, and has to be mapped, because it's the same Yang model on both sides, on the device side and the data store side. So we are literally going through this because this work is new. There's no real good sample illustrations in open source. So we're going through the specifics of exactly what message needs to be sent and how do you identify the manage object, and then how do you map it in a way that's a little bit more generic, at least so that CPS can deal with different applications.
Right. So I think that will be apparently important when you try to do third parties or
Yes.
device definition. In
Yes.
some cases, as ORAN O1 allows you to manage RU through DU. So it will be important to know two different devices at the element level and one device at the communication level.
True. The RU specific. We can. Why don't you continue? And I'll comment
Yep.
more.
Yeah, sure.
No, use your
So
time.
so since I was talking about like this, the capabilities of the CP, I mean this DMI plugin can be extended. Like we can have a third party DMI plugin which could actually which could actually listen to other standard events. It may or may not be VES. It can be of any format, but if it is capable of producing a DMI data ABC event, then I mean, basically it can be used as a multi-vendor solution. So this is how the capability can be extended. Now, since I was talking about this DMI data ABC event, so in the next slide, we can actually see how it looks like. So here, I mean, the payload inside this event attribute is RFC 8641 compliant, which is for subscription to Yang notification for data store updates. So these are the important fields which you have. So in the next slide, we have an example of how it would actually look like. So I mean, we basically we have to map the fields from VES event and convert it to this DMI data ABC event, which should actually be processed by the CPS components. So yep, this is all I have for CPS. So handing over to Shankar.
So thanks, Vishal and Priyank. It's 12, but I guess we started 4 minutes late. So I'll just take about a minute now. So in conclusion, this, depending on your perspective, this might seem like something like, hey, this is all routinely done all the time. What's the big deal? It's a non-trivial problem to keep track of configuration and in an SON use case or an automation, any application use case in a consistent manner. And especially from a 5G and ORAN perspective, things are changing in terms of how RAN information flows over O1 interface. And the CUDU is O1 and the RU, we have not done the open front all M plane part, but it's similar principles apply. And so here, this example is showing how you can be aligned with ORAN and Yang and NetConf principles and show a very nice illustration of a complete data store solution. And we believe we have converged on a good design. And like I said, just poring over the details as to what should be in the message. And like Mudassar asked, okay, how do you identify the manage object? Because it's coming from a network function, right, which is generating that VES message. And so what is a network function? Which is the netcom server responsible for the network function? There are all these dimensionality issues sometimes. But the updates have to be efficient, and we made a judgment call, a design decision here. We update the database and generate a notification. And this work, we believe, should be reusable, and that's the reason for presenting this. Essentially, it's like a solution approach presentation rather than the implementation will come in the next event. But it should be relevant to anything in ORAN software community, any LFN projects dealing with RAN, NF, and anything to do with O1 interface. And in general, any Yang-based network function in ONAP. And a quick follow-up, Mudassar, on your comment on, yes, we focused on the configuration update, which is the notify MOI changes. And so the MOI creation is being done manually. And so that can come as a next step. It has more complexity, but it'll all be initialized with a view in a way that can flow over both on the ransom side, which creates objects, and on the CPS side, which creates a CM handle and initializes the database. But for this release, those parts will be done manually. So we focus on these mapping and fields and things like that. And once we do this, we can do the other parts. Thank you.
Yeah, that makes sense.
Yeah.
I think it's a good work. And I believe once you do the day one configuration, those manage elements and manage entities can be already sorted out.
Yeah. Thank you. Yeah. Any other questions or comments? And we didn't put emails here, but if you go to the ONAP wiki and just type SON CM or CPS, you'll find this. And then it's being tracked as a network CM in the 5G SON use case. And if you have any questions, reach out to me. Any of us. We should have put emails. I think our emails should be there in the wiki,
Maybe you
page
can
for this talk. Yeah.
Yeah, maybe if it's not, maybe you guys can update it. Usually shorthand names don't really translate to.
I'll
digging up
do that. I'll
URLs.
just put that here and when we update the slides. Thank you.
Thank you.
Okay,
Okay, Shankar, thank you so much.
thank you. So if there are no other comments or questions, I'll stop recording now.